All right, let's talk about one of the coolest, most out there ideas in all of science, wormholes. And not just as some fun idea from the movies, but as a real theoretical possibility that could totally change everything for humanity. So let's kick things off with a little glimpse into what that future might actually feel like. Seriously, just picture that for a second. An Earth that isn't just our lonely little home, but is the bustling central hub for the entire galaxy. You could just pop down to the station and grab a ticket to a planet orbiting another star. And believe it or not, this wild idea is actually grounded in some pretty serious physics. And that's the big question, right? Could we actually do it? I'm not talking about traveling for thousands of years in a spaceship. I'm talking about taking a shortcut, a cosmic back alley that gets you from here to there almost instantly. But how on earth would that even work? Well, to get a handle on that amazing vision, we've got to talk about the physics. We need to get into the nitty-gritty of what reality is actually made of, this thing we call space-time, and how we might, just might, be able to bend it to our will. So what exactly is a wormhole? You might hear physicists call it an Einstein-Rosen bridge. Basically, it's a hypothetical tunnel that connects two totally different spots in space-time. It's the ultimate way to cheat, to skip the long journey and just appear somewhere else. Now, here's the classic way to think about it, and it's a great one. Imagine the whole universe is just a flat sheet of paper. To get from one side to the other, you'd have to crawl all the way across, right? But what if you just folded the paper? Suddenly, those two distant points are right next to each other. Then all you'd have to do is poke a pencil through, and boom, that little tunnel, that's your wormhole. It sounds almost too easy when you put it that way, doesn't it? Just fold space, poke a hole, and you're off to another star system. Well, as you've probably guessed, it's not quite that simple. There's a massive, massive catch. And here's the first huge problem. Our current understanding of physics says that a wormhole would be unbelievably unstable. It would slam shut on itself so fast that not even a single photon of light could make it all the way through. So for travel, completely useless. Okay, so if we're going to build our galactic superhighway, we need some way to prop that cosmic door open. And to do that, we need to find an ingredient, something so weird, so backward from everything we know that we're not even sure it's real. And this stuff is called exotic matter. And I'm not kidding, that's its actual name. It's a type of matter that's only theoretical for now, and it would have properties that basically break all the rules. Specifically, it would have negative mass. Think about it like this. All the normal stuff in the universe, you, me, the planet, the stars, it all has positive mass. It has gravity. It pulls things in. Exotic matter would do the exact opposite. It would have a kind of anti-gravity. It would push things away. And it's that gravitational push that you would need to line the inside of the wormhole with to physically force it to stay open. So let's just imagine for a second. Let's say we figure it out. We find some exotic matter, and we build a stable wormhole. Well, the thing is, in solving that one huge problem, we would accidentally create a much, much bigger one. Because we wouldn't just be building bridges across space, we'd be messing with something else entirely. You see, when you have the power to bend and shape space-time like that, you're not just playing with distance, you're playing with time. And this is where that beautiful dream of a galactic hub starts to look a lot more like a nightmare. Here's the kicker. Physicists have figured out that any wormhole that's stable enough to travel through is, by its very nature, a time machine. There's no way around it. You could, say, fly one end of the wormhole around in a spaceship at near light speed, and you'd create a time difference between the two ends. Go through one way, you jump to the future. Go through the other way, you jump into the past. And that breaks the most fundamental rule of the universe, causality, cause and effect. It's the simple idea that things have to happen in order. You have to flip the light switch before the light turns on. It's the foundation of logic, of everything. And this is the classic example that just melts your brain. If you go back in time and stop your grandparents from ever meeting, then you're never born. But if you're never born, how did you go back in time to stop them in the first place? It's an impossible loop, a logic bomb that reality can't solve. And stable wormholes throw that door wide open. So that brings us to this enormous choice, this cosmic dilemma. On one hand, we have this incredible vision of a connected galaxy, all thanks to these shortcuts through space. But the very key that unlocks that future also seems designed to completely break reality. So here it is, laid out plain and simple. You've got the promise, a true galactic civilization, instant travel between the stars, and Earth right at the center of it all. And then you've got the peril,
breaking the law of cause and effect, creating paradoxes that can't be solved, and, risking reality as we know it.
And really, that's the bottom line. The quest for a wormhole hub isn't just about physics or engineering. It's a deep philosophical question. What are we willing to gamble to achieve our wildest dreams? And is a truly connected galaxy worth risking reality itself? It's a huge question to think about.